What if finding the best AI model for your use case was as simple as submitting a list and getting a leaderboard back? In this video, I'll show you how to build your own LLM leaderboard using AWS Deadline Cloud. You pick the models, you pick the benchmarks, you submit one command, and every model gets tested on its own GPU simultaneously. For context, large language models, or LLMs, are what's behind tools like ChatGPT. There are hundreds of open source ones available on Hugging Face in different sizes and specialties. The challenge is, how do you know which one is best for your needs? You benchmark them, run standardized tests, and compare scores. But doing that manually means spinning up GPU servers, loading each model one by one, and compiling results yourself. This job bundle automates all of that. It uses vLLM to serve each model and LM evaluation harness to run the tests. With Deadline Cloud, each model runs as a parallel task on its own GPU worker, so testing 5 models takes the same time as testing one. Let's get started. We'll begin with the one-time setup. Feel free to skip this if you already have a farm with a GPU fleet and a Conda queue environment with Conda Forge. Create and name your farm, then create a fleet. Name it, and then select Service Managed for the fleet type, meaning Deadline Cloud spins up and spins down the services for me, so I don't spend more than I have to. I'm selecting On Demand for my instance market type. Make sure to make it a GPU accelerated instance. I'm then selecting an A10G GPU, and am picking a worker size that is big enough to handle my benchmarking jobs. I'm also choosing a minimum of 64 gigs of memory, so I have enough headroom for my models to run. Lastly, I'm changing my minimum number of workers to 3, same as the number of LLMs I will be benchmarking. That way, all 3 LLMs can be run and tested by a different worker in parallel, taking only a fraction of the time. Skip to review and create your fleet. Then create a queue, attach an S3 bucket for your files, associate the fleet you just created, and make sure to have the default Conda queue environment creation checked. Then select Create Queue. Now let's move on to building our leaderboard. On my local machine, I install the Deadline Cloud CLI with pip, then configure the CLI with my farm and queue ID so it knows where to submit jobs. This can also be done within settings in the Submitter GUI. I also clone the needed job bundles from the samples repo in GitHub. Now, there are 2 things to choose: which models to compare and what to test them on. Any model that vLLM supports works. You can find them all listed on their docs here, also linked in the description. I don't need to download the models ahead of time. Each worker pulls them automatically when the task starts. I open the job template and go to the parameter space. Each entry is a model ID from Hugging Face. I'll compare 3, Quen 2.5 at 500 million and 1.5 billion parameters to see how size affects quality, plus Pythia 1.4b from a different developer as a cross-family comparison. For benchmarks, there are hundreds available through LM Evaluation Harness. Common sense reasoning? Choose HelloSwag or Winogrande. Broad knowledge? Choose MMLU. Math? Go with GSM 8K. Code generation? Human Eval. You just pass the names. The test datasets download automatically. The full list is linked in the description. Launch the Submitter GUI with this command. The default set tests common sense reasoning, a solid general-purpose starting point. But you can override it with the submitter with whatever matters for your use case. Click Submit. In the monitor, 3 tasks spin up, 1 per model, running in parallel on separate workers. Each pulls its model from Hugging Face, starts a vLLM server, and runs all benchmarks against it. All 3 finish in roughly the same time. Then the aggregate step kicks off, collects all scores, and produces the final leaderboard. All 3 models took just under 19 minutes to test all together. I download the output and open the results. Here's my leaderboard, a ranked table with each model's score on every benchmark, plus a mean. Quen 1.5 billion leads at 0.62. The 0.5 billion variant scores 0.50. Pythia lands at 0.48. I can immediately see the scaling effect and the cross-family difference. And it's as simple as that. Pick models, pick benchmarks, submit to Deadline Cloud, compare. Iterate until you find the right model for your use case. The job bundle is open source. Link in the description, along with the full list of supported models and available benchmarks. Clone it and make it yours. Thanks for watching.